Hello, Sai. Am I audible to you?
Yes, sir. I can find it.
Yes, am I audible to you? Just give me a second. Yes, not at me. Everything's okay now?
Yes, sir. So can you hear me?
Yes, I can hear you. Okay, so first of all, just mention me your name, for which organization you are preparing. Okay, and which subject have you prepared today?
I'm Sai Kumar and I'm preparing for HPCL interviews.
Just give me a second. Yes.
I'm Sai Kumar and I'm preparing for HPCL interview.
Hmm.
Today I
And
want
which
to give
subject have you
snap for
prepared?
heat transfer and fluid mechanics.
Okay, transparent fluid mechanics. What is your branch?
Chemical engineering.
Which one? Mechanical?
Chemicals, sir. Chemical engineering.
Chemical engineering, na? Okay, okay, no issue. Okay, so should we start now? Okay, so first of all, just tell me, coming back to the heat transfer here, how do you define the different modes here?
Heat transfer can be through conduction, convection, or radiation. Three modes are there.
Hmm. And what are the difference
Uh,
between these three?
So for conduction, it needs continuous substance.
Hmm.
When there is a temperature gradient, it can flow from. If we consider a solid iron rod, it can flow from one end of this rod to other end through temperature difference. Like when heat transfer from higher temperature to lower temperature. And for convection, heat transfer from solid surface to flowing fluid. That is
Okay.
convection. And
Okay.
heat and radiation is through electromagnetic waves.
Okay.
Heat
Specify
transfer
me
through
any,
electromagnetic waves.
specify me any practical example where all the three mode of heat transfer are simultaneously taking place.
Like in a
Any
furnace,
practical example. Hmm.
yes, in a furnace, it is at higher temperature. Heat
Hmm.
transfer through radiation as well. At the tubes, there is solid wall. Heat transfer by conduction takes place, and the fluid is flowing, like crude is flowing, oil
Hmm.
is flowing. There is convection also takes place in the tubes.
Okay. Can all the three modes of heat transfer occurs in a single media?
No, sir.
No.
Yes, sir. Solid. Yes, sir. So conduction can take place in gases also.
But if you just see,
It is possible, sir. For gases, it is
possible.
possible.
Okay. Okay. Just tell me one thing. Is radiation a surface phenomena or a volumetric phenomena?
What is the other thing?
Is radiation a
Surface.
surface phenomena or a volumetric phenomena?
It is volumetric phenomenon.
Volumetric. How can you say that?
Because
Hmm.
like, radiation doesn't need actual surface. Like, it can flow through vacuum also.
What is the meaning of volumetric phenomena?
I don't know exactly.
Don't know.
Sorry, sir, I don't know exactly.
Okay. Tell me the differences between the thermal conductivity and the thermal diffusivity.
Thermal conductivity.
Hmm.
Thermal conductivity. Heat flux is directly proportional to temperature gradient. The proportionality constant is called thermal conductivity, which is represented by K.
Hmm.
Then thermal diffusivity is alpha. Alpha is equals to K by rho C.
What does it physically signifies?
Like how much heat storage capacity.
And what are the unit of thermal conductivity and thermal diffusivity?
Thermal conductivity watt per meter square Kelvin, and
Hmm.
thermal diffusivity is meter square per second.
Okay. Okay. What does Nusselt number represents?
Nusselt number conductor resistance of solid to the convector resistance of fluid. Like
Hmm.
we can use it for finding out the heat transfer coefficient for heat exchangers.
And what is its minimum value?
So, from
Hmm?
1 to several hundreds.
Yes.
I don't have I don't know exactly, but Prandtl number can be from 1 to 50 onwards, and Reynolds number can be from 1 to several thousand. So it is like the product of Reynolds number, Prandtl number by using Dittus-Bolt equation and Sedate equation.
Okay. What does Nusselt number physically signifies here?
It is like how much conductive resistance of the fluid to the conductive resistance of fluid.
Okay.
I'll check once.
And what are the governing parameters in the case of free convection as well as the forced convection?
In natural convection, if there is a if there is a temperature gradient which leads to buoyancy forces, generation of buoyancy forces, which leads to natural convection.
Mhm.
And if there is a pump, we are using pump, so it is forced convection.
Okay. Let us say if there are two plates here. Okay. Two rectangular plates are there. One is placed in the horizontal configuration and the other plate is placed in the vertical configuration here. Now, if both the plates are maintained at the same temperature of, let us say, 100 degrees Celsius, and it is placed in a room of 20 degrees Celsius here, which configuration will cool faster?
Air is flowing from.
Normally the air is present in the room here in stagnant conditions. Now tell me which configuration will cool faster here, vertical one or a horizontal one, and why?
Horizontal one will cool faster because when there is a hotter surface, density will be the gases. The gas density will be higher. The gas density will be lower at higher temperature, so it goes above.
Then that is okay, but which
Gas will be
configuration
displaced
will cool faster here?
horizontally.
Horizontal. Okay. ठीक है. Okay, do you know anything about the heat exchangers?
Yes, sir.
Just tell
Double
me
pipe heat
classification.
exchangers. Yes, sir. Several types of heat exchangers. Uh,
Mhm.
Double pipe heat exchangers, shell and tube heat exchangers, plate heat exchangers, and then
Mhm.
scraped surface heat exchanger.
Have you heard about the recuperative,
Sir,
recuperative type of heat exchangers?
electroplating.
Yes, recuperative.
Electroplating heat
Regenerative
exchanger.
type of heat exchangers.
Yes, sir. Regenerative type of heat exchanger.
Okay. What are those? Any practical example of them?
Regenerative type heat exchanger, like there is one solid object. We pass the cool medium first, and then after passing the cool medium, it replaced with we will replace that cold medium, and again we will pass the hot medium. So like
Mhm.
if both are compatible, we can use regenerative type of heat exchanger.
Okay. Okay. The radiator which we use in the automobile engine, the radiators. Okay. Under which category will, it falls here?
Is cross flow heat exchanger.
Cross flow. How do you find the LMTD?
By using correction factor, we'll find out LMTD by regular method, delta T1 minus delta T2 by ln of delta T1 by delta T2, and we will multiply it with correction factor FT.
Okay, ठीक है, no issue. Okay, Sai, let me find my feedback here. See, first of all, you have to revise one more time your heat transfer subject here because in some questions you are doing some mistakes here by delivering the answers. For example, when I have asked you that what is the unit of thermal conductivity, there you have given me the answer watt per meter square Kelvin. That is the wrong one here. Okay, the watt per meter Kelvin is the unit of thermal conductivity, and the watt per meter square Kelvin is the heat transfer coefficient here.
Heat transfer coefficient.
Okay, na? And coming back to the classification of heat exchangers here, just see. You all, normally we know the parallel flow, counter flow, or a current flow here. Sorry, parallel flow, counter flow, or a cross flow here. Okay, all of these of heat exchangers are comes into the category of the recuperative model. So recuperative heat exchangers are those heat exchangers in which the heat is transferring from one solid surface to another solid surface here. Okay, through the pipe medium. I can say from one fluid to another fluid through a pipe surface here. Okay, those are the recuperative. So shell and tube type of heat,
Non-contact type.
shell
It
and
is
tube
like
type of heat
non-contact type.
exchangers. Yes,
It's like non-contact type.
yes.
Non-contact type
And
heat exchanger,
And
electroplating heat
and
exchanger.
coming back to the regenerator, the explanation you have given me is correct here. And the practical example, if you just see the L Youngstrom type air preheater, which we use in the gas turbine power plant, are the example of the this one here, regenerative type of exchangers. Okay. Coming back to the dimensional number are very, very important for you for the heat transfer subject as per the as well as for the fluid mechanics effects here. Okay, even though you know the definitions here, but you don't know the mathematical physical significance here. Okay, first of all, just if you just see the Nusselt number. Nusselt number basically compares the convection resistance, right? And so the conduction resistance of a fluid with the convection resistance of the fluid itself. Okay, that means you are comparing the heat transfer rate through the fluid by means of convection over the conduction part. Or you can say it is representing you the enhancement of the heat transfer which is taking place by means of convection over the conduction here. Okay, because you whenever we define the conduction, it is basically a sum of conduction plus advection here. Okay, so you can say the Nusselt number value is always going to be more than 1 here. So it is not having a specified minimum value, okay, but it is always going to be more than 1 here. Understood? And the question which I've asked you related to the vertical plate and the horizontal plate here, in that case, the vertical plate configuration will cool faster. Why? Because if you just say if it is placed in a room, what will happen? The air will make a contact on both the sides here, and the air will find it very easy to flow over the plate here. So I can say the convection current will flow easily without any resistance. But if you just place the plate in a horizontal configuration, the bottom layer, okay, the heat will not be able to transmit from the bottom layer because it is the convection currents are not able to flow now. It is facing some resistance. Okay. And one more question I've asked you related to the all the mode of heat transfer taking place in a single medium. Is it possible or not? See, first of all, you have to remember that in a single medium, it is not possible to have all the three mode of heat transfer in a single medium I'm talking about. Okay. But in practical scenario, all the three mode of heat transfers are taking simultaneously here because we are dealing with a number of different mediums here. You have given me the example of gases here. Generally, in the case of gases, there is a random motions of atoms and molecules here. Okay, so due to the randomness here, the heat transfer is formally taking place due to the convection only. There is no conduction taking place here. Okay, so generally in this case, radiation plus convection, these two phenomena are dominating over the conduction part. But if we just take an example of solid body, in that case, what is happening? The heat transfer is taking place by means of conduction, okay, or by means of radiation part here. Okay, and also one more thing, I have also asked you that radiation is a volumetric phenomena or a surface phenomena here. The answer is correct here. It is a volumetric phenomena, but the explanation is not correct. Okay, actually,
Volumetric phenomena means
volumetric phenomena means that all the atoms and particles which is being comprised in the body here, they are radiating some energy. That is the correct one here. Okay, or I can say any phenomena which is taking place all over the body, either on this outside or on the inside here, it is can be considered as a volumetric phenomenon. Okay, but if you just see, whenever we are doing the analysis of a radiation part, the radiations are coming out from the surface. Even though it is seem like that the radiations are coming out through the surface, but it is not a surface phenomenon. It is also volumetric phenomena because inside the body, the atoms and molecules are also radiating the radiations, but but they are getting trapped inside the body itself. Okay, that is why it is considered as a volumetric phenomenon. Okay, so if you have any doubt, do you have any doubt here right now? Everything is clear.
in McCabe's Smith book, like for conduction, it can be possible in gases, liquids, and solids. It is mentioned there.
No, no. The conduction can take place in the solid, liquid, as well as the gas. That is the correct one here. But actually, what happens here in the case of liquid and gases, we have a randomness of the atoms and molecules also. So, due to this random nature, the conduction is dominated by the convection part here. So, their convection part basically dominates the conduction here. So, that is why whenever we are finding out the Nusselt number, it always come out to be more than 1 here. Okay, generally the value of the thermal conductivity is very, very low. So you can assume it like that. Whenever a solid plate is there and a fluid is flowing over the plate, then what will happen? The close to the solid surface, there is a formation of a stagnant layer. Close to the solid boundary, there is a formation of a stagnant layer. Now the heat is transferring from the solid body to the stagnant layer by means of conduction only, because the atoms and molecules will become stagnant. But from the stagnant layer to the further upper layers here, the heat is transferring by means of convection. There is no conduction taking place here. Understood? Any other
Yes.
doubt? Okay. Okay, Saikwan, now you can leave the meeting here.